Hello and welcome to QuickTechie. In this session, we are going to discuss about Apache Spark and MapReduce. So this is an agenda. So let me start with the Spark versus MapReduce. MapReduce is an algorithm or a technique to process large volume of data. It consists of two phases as below. MapReduce has very it is known as it is a very specific to Hadoop framework, but that is not the case. It is a general programming technique or algorithm which you can write using Java, Scala, Python, C++, or even using any other programming language. You can create MapReduce algorithm. So it has a two phases as we discussed, map phase and reduce phase. So we'll discuss about this and we would prove this is not a specific to Hadoop framework. So now let's move here. I'll discuss cluster manager bit later. So any programming language when you learn, you need to know the hello world application for that programming. So in the Hadoop MapReduce, the hello world application is a word count application. So let me go through this what word count application. So basically in this file we have 5 lines, correct? And if we wanted to count how many times each word had appeared in this file. So by looking at the file, you can simply know that Hadoop exam word is 5 times in this file. Learning is again 5 times in this file. But Hadoop keyword is only 1 time in this file. Spark is only one time, and AWS is 1 time. So this is, let's assume it, if you have a 1 terabyte of size of the file where millions of record in that file, how would you do this word count using this MapReduce algorithm? So first we have to do mapping. So that is the first phase of your MapReduce algorithm. So that is called map phase, as you can see here in this. Okay, so this is the map phase. What you would do, basically you would read each line, break the line with the word. So here, I'll break here, and 3 words would be generated, and for each word we would put a count 1. So Hadoop exam is one keyword here, learning is 1, and Hadoop is 1. So these 3 words. So as you can see here, we are putting basically 1 1 for each of them. Similarly, for second line, we are generating this and we are putting 1 1, and Spark is another. So that is called your map phase. Now similarly, we have a reduce phase, but reduce phase is more complex. It is not that simple. If you are working in a Hadoop environment, huge files where hundreds of different computer or nodes are in the cluster, then you need to transfer this data across the network. As you can see, different arrow is showing here how data is transferred across the network. So I need to transfer or accumulate all words with same word and put it together so that I can do the calculation. So here you can see Hadoop exam is this. So we are transferring to this data set to here. So all Hadoop exam is here, and you can see 1 1 1 1 we have put here because it is appearing 5 times in this whole data set. Similarly, learning here 5 times in each data set, and then Spark is a only 1 time in this data set, AWS in this data set. So we are putting that. So that is your reduced phase basically, correct? So as you can see here, this is basically I would say shuffle and sorting, correct? Here this is shuffle and sorting phase here basically in this. Okay, so as you can see, this is a shuffle and sorting, and we have data accumulated on the respective node basically. Now we would do the reduce phase. Reduce phases means basically you are calculating this 1 1 1 1 together and reducing to summation. Basically, it's a 5 here. It's a 5 here, correct? And Hadoop is 1 only, and this is 1 only, correct? So this way you can see in this diagram, this is your reduce phase. So that is map reduce basically. Correct. Now let's discuss about some few point of to understand MapReduce. As you can see in this algorithm or concept or logic, which you can write in any programming language as we discussed. Correct. Even Spark uses this concept internally. So when you write your program in Spark is also using this concept internally, and whatever calculation you are submitting, it is trying to convert into a MapReduce itself. So because it is again Spark is a cluster based, and this has to run across thousands of nodes in the cluster. So that is the reason the Spark is also using basically MapReduce algorithm, but the way it is implemented differently using a internal Scala RDD. Basically it uses internal, correct? So and implemented using Scala programming language. So why Hadoop is still used? If you have to write this MapReduce on 10 terabytes of data, so how would you do that? Because Spark does not provide any storage or anything, correct? It's an in-memory computation in a Spark, but Hadoop is a storage as well as computation engine. Using Java multi-threading code, it can take more than 24 hours to complete this calculation. Suppose you need to perform same calculation using single machine with 10 terabytes of data, this word count application, then this would take like more than 24 hours. Even you can write highly multi-threaded programming. Even machine learning and data science algorithm needs to do same thing more than 1,000 times on the same data set. Hence, you cannot wait and rely on single machine or of Java program to do this. So basically, whatever you are writing in this machine learning or this word count application on large volume of data, you can perform the same thing using single machine and in any programming language like Python, Scala, Java, C++, but this would take huge amount of like a lot number of days to process your data if it is a 10 terabytes or 100 terabytes or it volume is in petabytes. So that is where you need a cluster, basically collection of machine to process this data in parallel. Okay, basically, so this you need cluster is basically hundred thousands of nodes in your cluster, and you would process this data across the machine. So that's where you need a like basically this what I would say a huge number of machine and cluster to be created. Yeah. This needs to be horizontally scaled to run MapReduce algorithm on thousands of nodes in parallel. Hence, you need a framework which can distribute workload across thousands machines. So, which framework is for helpful to distribute your workload across thousands of machines? So, it's not like simply you collect thousands of machine and you start writing your code and run on this. Correct? It is not possible. You need a framework which can handle to distribute your computation across these nodes, correct, as well as data across this node, and final result needs to be accumulated and saved on the disk at one place. That is what you need it. So that is where is the framework comes in picture, that is MapReduce framework, as well as for storage is HDFS engine you would use. So Hadoop MapReduce API is capable of doing the same thing. Similarly, Apache Spark can also perform same responsibility. Hence, using Hadoop or Spark with thousands of nodes of cluster, you can perform this entire calculation in a few minutes, even less than that. That is possible, correct? But if you use single machine, then it would take like so many days to process your 10 terabytes of data. You increase number of nodes and computer you can say in your cluster, and it will give you a result much faster, correct? So that is what your Hadoop or MapReduce can do. Similarly, in Hadoop we have a HDFS. This is a distributed file system. So suppose if you have a hundreds of terabyte of data, and how do you do that? That is possible to store in a single disk? That is not possible, correct? So what you can do, basically you can have 100 different computer, and in each computer is store 1 terabyte of data. So with 100 computer you can store 100 terabytes of data. So that is where you can have this. Well, so similarly, you have to do 1000 terabytes of data, then if your each machine is capable of storing only 1 terabyte of data, then you need 1,000 machine. So this is all we wanted to be look as a single machine. Even you are using a thousands of machine, but for a storage perspective you can see like this is my single machine which storing the all data. So like this is your cluster basically, correct, and which has a thousands of nodes. So if you are storing 1,000 terabytes of data in this, so how do you basically select data from only one machine, and it appears you to you the data is coming from a single machine. So that is where this HDFS helps you to store your huge volume of data. Using HDFS, that is possible and relatively cheaper. Even you cannot achieve this using Spark framework because storage is not provided by Spark. Spark is a computation engine only. So that does only in-memory computation. So Spark does not provide that feature to storage the data. So Hadoop is still being used. The reason being its HDFS capability and various other framework it supports. Even Spark extensively uses HDFS to read-write data. Now let's move and understand HDFS mode. If we have 10 node of cluster, each can store 1 terabyte of data. It means you can handle 10 terabyte of storage across the nodes in Hadoop cluster. This, as you can see in this diagram, there are 10 computers which are connected to through network each other. Correct. So this is a Hadoop cluster with the 10 nodes. This is not easily achievable. However, there are other options available nowadays to store 10 terabytes of data or high volume of data. If you want to store, you can use cloud storage. So Spark and Hadoop are directly connecting to the cloud now to rather than storing on their own computer. So that is where the Google Cloud Storage, Amazon S3, Azure Storage are coming in picture as well. Many enterprises, because of compliance and regulatory need, don't want to use cloud storage and they can use HDFS storage. So private data centers are still using a HDFS as a storage. So if you would see, like, there are various reasons behind that they need their data to be in premise or on prem, you can say. So they are still using HDFS. So and they cannot directly go to the cloud provided storage like Google storage or Amazon S3 or Azure storage or something like that. Now let's move. So what is distributed system philosophy? Run your job on each node in parallel. So as you can see in this diagram, if you have written this program, correct, and you wanted it to run across the machine, so on a different data set of the machine. So what you would do, you would transfer this code to this machine and this code to this machine like that, correct? So on each machine you would transfer your code and that would run separately on each machine. Basically on separate data set this would run, correct? This is data set on this and those are called in cluster terminology a task basically, and this task is executed, this task could be executed, this task could be executed, this task could be executed here. And once task is completed, it would send result back to this client program. So this is client which submit. Okay, sorry. So this is a client which submit this program and result after calculation would send back to this. So legacy style send data to code. And legacy style was like that. You would be sending your data to code this way, basically, correct? Do you see in a big data world it is possible? Obviously not possible to send data back to the single node because it cannot handle that volume of data and not possible. Rather than code you are sending, you are send so rather than data you are sending, you are sending code to the data. So that is the very important difference you should remember, and you would see this question in your interview as well, correct? What is the philosophy in the big data world now? So source code can be anything like Spark, Scala, PySpark, MapReduce, Java code, etc. that you can transfer to the different node in your cluster. Final result from all the nodes will be aggregated and returned or saved to this desk basically, correct? So that is distributed system philosophy. So what is the basic here? Very important thing is not send data to code, send code to data, correct? So you are sending your code. This is your code to data you are sending it. Okay, now let's move further. Hadoop yarn. So that is very important thing. Even if you are using Spark and not Hadoop, then also you need to know what is yarn and how it is being used. Yarn is yet another resource negotiator, is a framework which is specially created by Hortonworks, and this is now part of your Cloudera as well, which is both the companies are merged. So this is yet another resource negotiator was created by that and then later donated to Apache Foundation. So if you want to manage 10,000 nodes of the cluster, how do you do that? how do you distribute your workload? How do you know, like in my cluster, how much RAM is available, how much disk space is available, what resources are available, like how much CPU is available. So this all resources are, and its negotiation, allocation, and everything can be done using Yarn. That is yet another resource negotiator. If you use Cloudera Manager utility, you can manage hundreds of such cluster as well. Like if you are using this Cloudera is a basically vendor for providing big data solutions. That is the platform called CDP, Cloudera Data Platform, which is basically underline is a one of the component is a Hadoop in that, and they can provide one utility or UI which basically manage hundreds of different cluster as well. Like managing one cluster itself is a challenge, correct? Like if you create 1,000 node cluster, and if you need to manage it, how would you manage it? So that is using Yarn. Basically you can use this, and yeah, cluster resource manager and many other things. But now if you have 1,000 nodes of 5 different cluster with 1,000 nodes in each cluster, how would you manage this 5 cluster together, basically using it? So Cloudera Manager, that is the utility which Cloudera provides to manage 5 different uh, cluster using single window, basically, correct? Single UI. They will provide you to manage all this cluster. So they can you can manage hundreds of different clusters using Cloud Manager UI. Correct. So assigning resources from, so what is Yarn? So Yarn is to allocate the resources to your job. So suppose in my cluster there are 10,000 nodes and each node has a 256 GB RAM. Correct. So how much amount of memory I have, you can multiply and you can see like huge terabytes of RAM you would allocate it. CPU, like each machine has a 64 CPU. Then assume it how much CPU you have. 10,000 multiplied by 64, that much CPU you have. Now you submit a job and you need a like 1,000 CPU and 1,000 GB RAM. So that is what is needed for your application or your job which you are submitting to cluster. So how would you do that? You go to your cluster manager, that is Yarn. You can see one of the component is in the Yarn, basically resource manager, that is called. You ask for resources to this, like I need a 1,000 GB of RAM and 1,000 CPU for my application. Can you allocate me on from this cluster? So Yarn will see and see the current status of the cluster, and it would tell you like yes, this many resources are available, and you can submit your application that would run in parallel on with different nodes. So that is what Yarn is help. So that is the purpose of yet another resource negotiator. So that is cluster manager. Even if you are using uh, Spark, you would be using Yarn if you wanted to run your job across different machine and to be management. So Yarn is the one. If you running thousands of jobs and 10,000 nodes, etc. So this all management of the job allocation, resource allocation, task allocation is happening using this. Which nodes process what and how many nodes should be used by each job. So this is all responsibility of the Yarn. This will be managed by the Yarn framework. So that is what it is basically. Okay. Now let's move and understand what is iterative algorithm. You would heard like or already heard like basically Spark is very good for iterative algorithm. So what are the iterative algorithm? Let's try to understand first. So suppose if you read some data from the HDFS file system and you do some calculation, let's say calc 1, you need to do some performance on this read data, and then you would basically, if you are using Hadoop framework, you would have to, after calculation, you are generally saving your data back to HDFS. Then in next calculation, that is iteration 2, you again read data from the disk or HDFS platform and do the calculation, and result you save it and basically and in HDFS on disk again. So similarly, n number of iterations. So what you are doing here is n time reading your data from the disk and you are performing this calculation. So even your data remains same or something like that, you would always storing this data to the disk, and then final result would be saved in this kind of thing. So this is what your basically iterative algorithm. You are performing calculation, a different calculation again and again on the same data set. So what is the problem here? If you see, that is the main problem with the Hadoop framework or MapReduce. Basically, why when you read this data first time from disk, you do calculation, you're saving back to disk and then again reading from. So this is the main problem here basically. Why you always save into data disk again and then read again to do this calculation. So that is where Spark come into picture. They say this I don't need at all in between. I'll keep every data in memory. I'll keep data in memory. So this would huge and huge, like basically hugely helpful to reduce your performance, sorry, increase your performance and reduce the uh, latency basically, correct? So that is what it can, a Spark can do. So what iterative algorithm, you want to do calculation on same data again and again, but different calculation. So no, it's not a giving you a good performance. You are always reading from disk, load into RAM, process the data, and this is very slow basically, correct? So that is not a good thing. So this is the diagram you are showing here, like reading a from disk and loading into RAM is always a slow process. So you should not basically only as minimum as you should do if you want to run multiple times calculation on the same data set. So you keep your data in memory. So if you heard like caching your data, correct? So this is one kind of caching which you would keep your data in memory. So that is what Spark can do, but MapReduce is not doing that. So what are the shortcomings of the MapReduce? Hard to manage. MapReduce is hard to manage and administrator, which is cumbersome and operational complexity, which with this, correct? Verbose API, if you do simply word count application, you have to write lot of code, which in Spark you can do is using single line of code if you are using Scala or Python or whatever, correct? So that is what the shortcomings for the MapReduce. Long running job with large batches of jobs with many pairs of MapReduce tasks. Each pairs an interpreted computer result is returned to the disk, local disk of, and that can create a problem and performance issues. Correct. So this is a repeated performance of the disk IO kind of thing, and this can create large MapReduce jobs could run for hours on or even days basically, correct? So that is the one problem. Failed to create general purpose engine. MapReduce is good for general purpose batch processing, but it fails for machine learning. A single MapReduce job, streaming, interactive SQL queries, interactive shell. So this is all not easily available. For that, you need a different component in Hadoop framework like Hive for SQL queries, Storm for streaming data, Impala for analytics, Jira for graph data, Drill, Mahout for machine learning. So you need different component, different learning, or different things. So this would increase overall complexity of the framework. So that is one of the reason MapReduce is not that successful and Spark took over it, because they are making this is a general purpose engine, which like if you learn one thing, it would be helpful across all this basically. They're doing all this thing. So that is what the advantage of the Spark framework. Now, let's discuss about few more points between Spark and MapReduce. This is where the Spark is different than MapReduce. Spark keeps data in memory, as I said, correct? So they don't write and read from the disk again and again. They once read from the disk, they would keep Spark keep the data in memory. Even your computer, which is holding data in RAM, is crashed. Spark knows how to load this data back from the disk, correct? So suppose if you are in a Spark cluster, correct, and if you are processing this data and this data is loaded basically in a Spark, it does some calculation kind of thing and this machine crashed, let's say. So Spark still know how to regenerate my this data, so they maintain this entire graph of calculation to regenerate the data. So that is one feature they provide, and they keep all data in memory, so they don't have to read again and again from the disk. How come Spark? can hold such a huge volume of big data and memory. Like, so basically, Spark is again a cluster, correct? If you have thousands of nodes in cluster and each node has 256 GB RAM, then total data in memory is like 100 into 256 GB. So this is like 256, sorry, 1000 multiplied by 256 GB is like 256 terabyte of RAM you are having. So you can hold that much data with this cluster basically, correct, and process it. So what are the reasons Spark is more successful? Spark do not have to read and write data from disk, which helps in improving computation and performance. Simple high level programming it supports, like writing a code in Spark is much easier than uh, Hadoop MapReduce. Spark uses the modern hardware caches very effectively. So if you understand, like there are, this is your CPU basically, or for each computer you can see, which is like on this one computer. Okay, so you are the 16 core CPU. Each CPU has their own cache, L1 cache, L2 cache, and L3 cache, which is L3 cache is shared across all CPU, and these are caches independently. So there is a huge improvement done to in a Spark to use modern hardware system, and that is done through Project Tungsten that we will discuss in next session basically, which helps to maintain or use this modern system memory management very effectively. So that's where the Spark has done a lot of work around this to make system highly performant for computation purpose. Okay. Now, reason for Catalyst Optimizer. Like this is another great improvement done by the Spark uh, committer to like create a Catalyst Optimizer. So Spark has its own data types, correct? So if you remember, like even Spark uses internally Java, correct? Like it basically run on JVM, but it has created its own data types. Correct? It does not use plain data type what Java is provided. You write your integer class and kind of thing, but Scala internally Spark convert into the format they need it basically, correct? Their own data type. Spark has its own optimizer. So that is all part of Catalyst optimizer. For each data type, Spark has an encoder. Encoder is serialize and deserialize the data. That is your SERD basically, you can say. Okay. They use predicate push down. That we'll discuss bit later. Correct. This what is this feature? Predicate push down. Spark, and next is Spark does not use Java built-in garbage collection. So I know Java itself has a good thing to manage their own memory management, but for such a latency sensitive application, cannot use the default garbage collection provided by the Java. So they don't use the Spark has its own garbage collection mechanism. Correct. So that is the so that so many improvement was done by the Spark to make this as a highly effective and efficient computation engine. These are all the reasons because of which Spark is performing 100 times more in many cases compared to MapReduce, and always much more performant than MapReduce. Especially Spark is very good for iterative algorithm, machine learning, data science related computation, and one field I miss is data engineering that is also required heavily. So that is also being used. So that is what Spark. Now again, let me tell you iterative algorithm we have discussed bit before, but now again let me show you. So what iterative algorithm? Spark keep the same data in memory or RAM until all iteration is finished, correct? So it reads data once from this file system and keep in this data in memory, and like iteration 1 algorithm 1 apply this, iteration 2 apply algorithm 2, or calculation 2, iteration 3 apply algorithm 3, and calculation 3, something like. So 100 times if you have 100 calculation, especially this is the scenario of machine learning where you have to do this. So you read your same data set. If you wanted to apply different calculation on the same data set, that's where you are going to use a this iterative algorithm on the same data set, and you keep this data in memory. If your application has only one iteration, then it doesn't matter whether you use MapReduce or you use Spark basically, correct? So But if your application has a more iteration, then go for the Spark. But however, Spark has done many other optimizations. So even for single iteration, it is much faster. As I said, like it has its own garbage collection, it has its own data type. It uses extensively in-memory data using CPU caches, basically, correct? So that is what it. So that is what iterative algorithm. Iterative algorithm is to applying various calculation on the same data set, and Spark keeps this data set in memory. So that is where it makes Spark very fast computation engine. Spark in various programming languages. Spark support like Scala. You can write code in Scala. You can write using Java. You can write code using Python, R, SQL. So anything. Everything is converted into a Scala-based object, and internally it convert to a RDD. Those RDD are very different than what you can write your own RDD solution. So or RDD based programming you can write. So does it matter which language you are using and performance impacted? No. Answer is no. You write program in any language. It doesn't matter for Spark because Spark internally convert into Scala and then RDD, and those RDD would be executed. So only your high level language would be changing, but internally it would be converted into the same structure uh, that would be executed in a Spark core framework. So as you can see in the block diagram, so if you write a program and using Spark SQL, or this is like different engine, Spark SQL, structured streaming, machine learning, graph frame, correct? And then you it goes to the data set or data frame API, you can use it and it generate the direct acyclic graph, basically, correct? That graph would be created, and this is our graph of RDD which would be executed here. So you can read data from HDFS, you can read data from Cassandra, HBase, Postgres, SQL, S3, MongoDB. So from any place you can read the data and it goes to this path. Now Spark as a single framework. So as we discussed, Spark can support ETL as well, extraction, transformation, and loading, basically, correct? So that is usually used by the data engineering team. So when you work terabytes of data to you want to clean the data kind of thing, correct? So you extract some information from terabytes of data, transform in some format, and then load into the database or some storage. That is where you can use this. So Spark can support this. Interactive query will do a lot of exercise around that, and will learn more, like data scientists analytics can do this ad hoc query using that. Structured streaming, like when you receive a real time of stream of data, basically, correct, like this. So those can be processed using Spark engine. Spark provides structured streaming solution for that. So Spark support, like other than storage, you can use for computation, various different kind of computation for this. You don't have to learn separate API for each part of the above framework. Same API works across all three purposes, basically, correct? Same underlying system and same performance across different types of workloads. So that is what Apache Spark provides. Okay.